Hey guys, I'd like to welcome each and every one of us to my discussion for today. I'm Ernest, and this is our Ernest Sciences and Mathematics TV channel. In our discussion today, we're going to look at an interesting topic of a linear momentum of a particle, and this is going to be assisting us in trying to, of course, create the relationship between this specific, aspect of a particle and its description of the concept of a linear momentum. Now, we have come across these specific terms of a linear momentum and a particle in our previous discussion, and therefore we are going to see the various characteristics which we have associated with this particular kind of a particle in terms of mass, velocity, and its components of force which have been applied. And of course, we are going to see those ones being used in order for us to find this specific description for the concept of linear momentum. Now, in this specific regard, we had described the concept of linear momentum from our previous discussion as a quantity which, a vector quantity which can be given in terms of the product of mass times the velocity of a particle under consideration. Now, in this specific case, this is going to be assisting us try to, of course, describe the concept of linear momentum. Now, from Newton's second law, we had mentioned that basically the rate of change of momentum of a body is proportional to the resultant force acting on that specific body. And in this case, we're going to see that this is going to be true for an illustration which we are given in terms of this specific description, now that we have mentioned Newton's second law of motion. And of course, this was what we referred to as the rate of change of momentum. And in this case, we're going to see that basically this can be given as a second way in which we can describe Newton's first law of motion, which was given in terms of force is the product of mass times acceleration. And in this case, we can see that this is basically going to be an analogous formula if we perceive it from this specific sense, whereby we're going to have mass as an intrinsic property given as that one being constant, and then therefore we're going to have a delta t. So this second aspect is basically going to give us the aspect of acceleration, and in a sense we are going to see that this specific rate of a change of momentum of a body that is proportional to the resultant force given in terms of f is going to be giving us the aspect of the rate of a change of momentum. Therefore, we can create a relationship which is going to be given in terms of this description, whereby the force applied, as we have said, is equivalent to the rate of a change of momentum given as dp over dt, which in a sense still gives an impression of dt, d over dt of this product of mass and velocity, just as I've just given in this specific first illustration, which, as we said, is basically, of course, the product of mass dv over dt, which is going to be giving us acceleration from Newton's second law of motion. Now we're going to look at a system of many particles of mass which can be given in terms of this specific description, whereby we're going to consider the masses of these particular particles given in terms of m1, m2, m3, which is going to form a system of particles to mn given as that one. Therefore, we can give this specific aspect of their total momentum given in terms of a particular description, whereby we're going to have the total momentum given in terms of p, and this p is going to be the summation of these individual momentums of the particles given in terms of p3, and then we're going to have this one p given as pn. So in this case, it is going to be representing the total momentum. And we're going to see that from our general description, whereby we see that this momentum can be given in terms of mass times velocity. Therefore, our momentum can be given in terms of this specific mass, which is a total mass times velocity average, which we're going to be, of course, evaluating from this specific sense. And of course, the total momentum of this specific system, then therefore, is going to be equal to the product of the total mass of the system, which can be found by using this specific, of course, elements of mass, and the velocity of the center of mass, which can be given as average velocity. And therefore, that's going to be giving us an implication of the concept of this linear momentum of a particle, whereby if we consider a particle, we can just give a description of this specific momentum using this particular aspect which we have given for the formula for momentum. But if we consider this is a particular particle as a system of many particles, then therefore we're going to do an evaluation by considering the mass elements of this specific particle up to a number n, and of course the specific momentum can be described using a range of momentums of these particles, which is going to be forming a summation of the same. So this is going to be giving us a general description of this specific aspect of momentum, which can be given using that particular description. So kindly check our description boxes for various links of other videos. We're going to do a range of evaluation questions which are going to be assisting us try to supplement on the same, and that's going to be forming our comprehensive discussion on the concept of linear momentum and other aspects of momentum like angular momentum, etc. So that is it for now, guys. Bye, God bless you. Catch us in our next video.